Hi guys, this is Lisa Knight, your instructor. I'm just wanted to give you some feedback on the discussions for Module 4 and the lab for Module 4. So the discussion you had in Module 4 was a pivot activity lab. One of the criteria is that you complete the pivot activity by the due date for the initial post. Most of you, 99% of you did that, and that was wonderful. I really appreciate that. And you also made your initial post by the due date as well. Kudos to you, another gold star. I want to talk to you a little bit about the types of responses that I'm looking for. When we do these activities, your initial post should be generally a summary of your findings. So it's important for you to include the data that you collected, and in this case, you would talk about the shapes of the velocity time graphs and the position time graphs. And you may talk about the slope of the velocity time graph since it's linear. And so you want to kind of summarize what you learned in the lab. And so in this lab, you should have seen that when you made a graph of position time, it was linear, meaning that in the horizontal direction, it was traveling at a constant speed, and you could even give that constant speed in centimeters per second because you do a linear fit and it tells you what the slope is. Also, you could see from the position time graph in the y direction that it was a parabola. And if you graph the velocity versus time for the y direction, you saw that it was linear, which means that it's changing at a constant rate. And if velocity changes at a constant rate, it's accelerating. So in the y direction, it should be accelerating. If you took a linear fit of that, you should get the slope in centimeters per second squared. So in your initial post, I was looking to see that you kind of summarized those findings and that you gave data, including slope values and descriptions of the shapes of your graphs. Your responses is where I need you to tweak. Most of you did a pretty good job with your initial post. You really did. What I need you to do is I need you to really concentrate on giving constructive feedback to your classmates. So here's an example. We have an initial post and we have response 1 and response 2. If I read response 2 to you, it says, "Hi, I took data on trial 3 as well. I think that we use a similar method of determining if the car has constant force. I also made a velocity time graph and looked at the slope to find the acceleration. My acceleration was a little bit different than yours. I found mine to be 119 centimeters per second squared. It's close, but a little different, which is probably due to difference in reading measurements or even picking different starting points." And then they went on to say that even though our numbers are different, I also concluded that the toy car has a constant force because it's traveling with a constant acceleration. So here they're agreeing with the person, but they're providing data from their investigation supporting that and showing how it may be similar, maybe a little different, but it's still providing the same conclusion. So I was looking for that, and if you didn't do that very well, I did take off points according to the rubric, and I may not have been, if you did it kind of halfway, I might have given you extra points. So that, on the rubric, you can only make 100, a 70, and a 40, but if you kind of almost did it correctly, I might have given you an 80 or a 90. So make sure that you're thinking about giving constructive criticism or constructive feedback. The other thing I want to touch on is your lab. So it's really important for you to watch the introduction videos to your labs because they give you the best example of the easiest, most efficient way to collect data so that you're not making a lot of data collection errors. Also, they go over the basic concepts. And in this lab, you graphed the horizontal position versus time and the vertical position versus time. And you wanted to determine if one indicated constant speed or if one indicated constant acceleration. Be careful, if something is constantly accelerating, it does not have a constant speed or velocity. That doesn't make sense because acceleration means that you're changing your velocity every instant in time, so it would never be constant. Well, unless you were changing direction. That's a fine point. In this lab, you would not have a constant velocity and a constant acceleration in one direction. That doesn't make sense. However, in the horizontal direction, when you graph the position time graph, it should be linear, which indicates a constant speed in the horizontal direction and no force acting in the horizontal direction. The vertical position time graph should have been a parabola, which means that it's accelerating. And if you made a velocity time graph from that data, it should be linear, and the slope of that should be the acceleration of the ball. So in the last question, you should have given me the acceleration of the ball and told me if it was very close to gravity, because according to projectile motion, the ball accelerates in the y direction at negative 9.8 meters per second squared. And you should have something very similar to that. So I am going to attach this document that has examples of what kinds of answers you should have given me for Lab 3 and for Discussion Forum 4, so that you'll have an example of what I'm looking for in your analysis during the lab and what I'm looking for in your participation in the Pivot interactive discussion forums. Please email me if you have questions.